sorts, unique, cat cut are just some of the commands we'll be learning about in this video. So, as alluded to in the first bit, we're going to be doing a few more useful commands, as promised in the last video. And actually, it's why I'm wearing the same outfit, because I've literally carried on from the last video. So, yep, we're going to be doing cat, we're going to be doing, well, we've already done cat, so I'm just going to kind of brush over that, but we'll be doing using head, we'll be using less, we'll be using sort, word count, sed is used for replacing one word with another one, and regex basically. We'll cover it more as we go on. So yeah, we're going to be doing some more useful commands in this video, and enough of that, let's get going. So I was going to cover a number of different things in this video. I'm just going to kind of fly through a few different ones. I'll try and remember everything I was going to cover, but let's just get going on that. So what I'm going to do here is I'm going to create a file called test, and I'm going to put hello world, my name is Drew. Okay, and we're going to use this file to do a load of different things. So the first thing we'll do is, I know I covered it a little bit in the last one, was cat. We'll do test, we've got cat, and you can see there we've got hello world, my name is Drew. And I appear to have a start space at the start of that, so I'm just going to quickly get rid of that. I'm going to create another file called test2, and we'll just put, and it's nice to see you. So we now have two files. Cat, as I said in the last video, test1, test2 can be combined into test3. And if I cut out test3, now I've got all of them, that content in this one single file. Great, that's absolutely fine. So I wanted those three files because I'm going to do a few different things now just to show you how stuff works in these next few commands. So the first one I'm going to go through is head. Head allows you to read the contents of a file, and using these files probably isn't going to be the best example. So I'm just going to do var log syslog for this one. And you can see here that I got the first, you got the first few lines of this. Now, I know for a fact that var log syslog is much longer than that, as we can see here. If I cut it out, there's a lot there. Head gives us the first, I think it's 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can change that though. We can say head, number of lines, 20, and it will give us the first 20 lines. It gives us the top of the file, basically. That's what it does. So that's head. There's also less, and less gives us the whole file, but it'll print it all out and you can essentially scroll through it. So if I do the same for var log syslog, we can now go up and down using the arrow keys, and we can page up, page down, and we can read through the contents of a file. This is a good way of reading files. It's better than cat in my opinion, because it means you can read the contents of a file. You can scroll up and down nicely without having to worry about scroll wheeling up and down. And obviously if you don't have a scroll wheel because you're on a keyboard only, then it's even nicer. So that's less. You can have a look at the manual for less, for example. Let's just have a quick look at that. And I don't believe you can do a number of lines on this because it just does the whole thing. So yeah, have a look through that. It's definitely worth a read, as all things are. There's also another command called tail, which is the opposite of head. So I can say tail to var log syslog, and that will give me the last 2 lines of var log syslog. And if I just cut out var log syslog, for example, real quick, we'll see that that's what we had. So yeah, last 2 lines there. There's another thing you can do with this as well, and you can say from the start, give me the first number of lines. So if I do that, what will actually happen is, I'm just going to use the test example for this actually. So if I do test3, I'm going to do a little bit of a hacky command here, but basically what I'm going to do is I'm going to cat out test3 into test4. Using a single chevron, we'll just put the content straight in. So if I cat out that now, we can see that. If I run that again, it's got the same content. Okay, if I put a double chevron, it will repeat over and over again. Like so, it will just append it. This single chevron overwrites, double chevron appends. Okay, so now if I do tail n to, let's go for 3, test4, we can see the last 3 lines. If we do +3, we can see I've got all of it bar the first 3 lines. So if we actually look how many were in there before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So actually it doesn't include the first line in the +3. So it starts, it's indexes from 1. So also, did you not notice how I just had to count those lines? How frustrating was that? Wouldn't it be nice if there was something like, I don't know, a word count? Well, there is. We can pipe that into WC and that will give us the counts. And there is lines, words, and letters. And you can do lines, words, and, oh, can I remember the last one? Is it letters? Yes. No, it's C. Yes, C. So characters, not letters. Actually, capital R, I'm not sure what that just did actually. So that's an interesting one. So yeah, WC can be used for word counting, which is really useful. We can also cat out test4 and sort the content into alphabetical order essentially. So just by putting sort in, we can get it in alphabetical order. And obviously we'll see all of those first and then all of those. Problem we've got there is we're kind of repeating, aren't we? So we can use another command called uniq, which is uniq, and that will remove any unique lines just to give us the ones. And now we're back down to 2 lines. However, they're now in a different order because of sort. You can sort reverse order as well. And then we can unique it, and now it's in the right order. There we go. So there's a few different commands there. We can count the number of lines with NL. So if we do test for NL, that will just give us the line numbers next to the actual lines themselves. So you'll see that in history being used. There we go. So that will just be using NL in the background. It will count the number of lines. We can actually do it ourselves if we wanted to. Look, we can do cat -- history. Remember that from the last one, and then pipe that into NL. And we've got a different number of lines. There'll be certain things that are slightly different in there, but yeah, there's some examples. The main thing being that we've been running commands since, and that's why we have more essentially. We have a few other things as well. So if I have a look at var log, we'll see these .gz from dmessage, for example. We went through dmessage in a previous video, so I won't be going through it right now, but you'll see that we can cat out var log dmessage, and that will give us all that information. But if we try to do the dmessage.1.gz, we'll get a load of binary output because we can't cat out that. Or, well, maybe we can. So zcat will allow us to cat out a .gz file. And there you go. There's the content right there. So that's zcat. We have xzcat as well, which is used for another kind of tar archive. Tar archive being a sort of zip. So we can tar things up. Let's have a quick look at that. So what I want to do is archive all of these up so I can send them all together as one file. So if I do tar create archive, let's see. We'll do it verbosely and we'll give it a file name of new tar, and we will go for test2, test3, and test4. So I'll do that, and then I will do that, and we should see we now have a new tar. And if we do remove test2, test3, and test4, we only have that left, and now we can do tar. We can do extract verbose if we wanted to. We could do tar gz as well, which is what that .gz was, but I won't get into that right now. It's just extensions on. But yeah, for now, we'll just do this, and the file is new tar. And if we do that, we get the contents back, and we can remove the new tar now that the person's received it and unpack the files. So that's a way of basically, it's like zipping up a file in Windows. That's what tar does. So we took the contents of these, dumped them into this new file, then we removed all them, and then to prove that it had worked, we extracted the tar and got all of those files back. And we can just confirm that by catting out just test4. There we go. So there's a few different things there. Another thing we can use is the translate command. So we can cat out test4, for example. Let's just cat that out. And what if we wanted to make all of this uppercase, for example? Well, we can use the tr command. So if I just quickly show you that, we've got all of these options available to us. And for example, we want to do everything to uppercase. So we can take lowercase characters to uppercase characters. And if you have a look, you've got set1, set2. So this is what you have and what you want to change it to. So I'm going to do cat test4. We will pipe that into translate, and we'll do brackets lower. We'll learn how to spell in a second, and I want to make them upper. This is quite a powerful command. I'm only going to show you the very basics of this right now, but this is one example. So if I cut that out, we can now see that all the lowercase has been converted to uppercase. So there is one example of that. We can change spaces to tabs and things like that. There's plenty of we can do with it, but that's just one example of the translate command. We can also create chars of our files. So say I wanted to send a file to someone and I wanted them to know that this is exactly what I gave them is exactly what left my machine. So you'll see it on some things that you'll download. There'll be a char sum or an MD5 sum or something like that. And all that would really be is a command called char. And then there is a few options here. You've got char1, char224, char256, and a few other ones. Honestly, just use 512. This is the most kind of secure one, if you like, the most reliable one. So if we do this and then put test4, we get this out of it. Now, if I sent this file to someone, they could then run that same command, and I would also send this string to them as well, and they would get that exact same string out of it. It will be the same every time. As you can see there, it repeats over and over again. So that's one way that they can validate the integrity of the file. And they can do the same with MD5, although it's not used as often anymore. So if I do MD5 sum, again, you'll get the same thing over and over again. So yeah, that's a way of doing file integrity. Another command I want to quickly show you is a way of splitting files out. I don't think this is used that often anymore, but you might have seen back in the day you'd have file parts. So actually you might see it in torrenting and things like that of large files. And this is one way of splitting files out. So if we take a look at test4, I just want to actually list the contents of it. We'll do test4. We can see we have a file of 371 bytes. Well, if I wanted to send this in 100 byte chunks, essentially, I could split this file out. So I could do split -b for bytes and say 100 byte file size, the file test4, and then you can give it a prefix if you want, but if not, it will just begin with X automatically. So if I just press enter, then we will see here, I now have XAA, XAB, XAC, and XAD. If I was to give it a prefix, I could do test split or something like that. And if I do that, we'll see test split AB, test split AC, test split AA. And those files, if I just cut them out, test split AA, now only have 3 lines in it. And that will be a total of 100 bytes. If we actually have a look at that, there we go. We have 100 byte file sizes, and then the leftover of 71 bytes is in the AD ones. So I'm going to go ahead and remove all of those. And just to clean up a bit, and yeah, so that's how the split command works. The final command I'm actually going to show you is something called sed. There are other commands I could show you here. So there's like an octal dump, for example. If I run od test4, this will give you an octal dump of the file, a bit like hex code, but I'm not going to get into that one right now. It's just a command that's to be aware of. There's another command called paste, which kind of merges files together. So if I do test3 and test2, then you'll see it combines them together. So this is useful sometimes. If you want to look at the manual page for that, obviously you can. And you can use delimiters, and yeah, you can basically merge lines of files. That's what it's for. The one I want to show you though is called sed, S-E-D. So sed allows us to replace words with other things. So if you've heard of regex, that's what this is for. If you haven't heard of regex, then it stands for regular expression, and it's a way of intelligently doing a find and replace, essentially. So there is a saying that says when some people are confronted with a problem, they think, I know, I'll use regular expressions. Now they have 2 problems. Regular expressions are a complex beast. They really are. And I am not getting into them today in this video. I might do one later on it, but to be honest, they're so complex that I think it's probably better that I just give an overview at some point, and then you go off on your own and try and figure it out. It's pretty complex stuff, but I will quickly show you an example of how sed can be used. So let's take a look at test4. And in there, we've got over and over again, hello world, my name is Drew, and it's nice to see you. I want to replace this for another name. And that name is going to be Ada, let's say. So I'm going to cut out test4. And in fact, I'm not even going to cut it out. I'm just going to use sed. I'm going to use I for inline. And then I'm going to do test4 just to get that in there. And in here, in single quotes, I will do a search for, sorry, yeah, just make sure I've got it right. We're doing a search for Drew, and we're going to replace with Ada. Now, if I just press enter here, it will do the first instance of Drew. If I want it to happen on every single line, I put a G on the end, which means globally. So I'm going to go ahead and press enter on that. I'm now going to cat out test4 again, and you can see every instance of Drew has now been replaced with Ada. So that's how sed works. Now you can see how this might be more powerful later down the line. You can do all sorts of searching. Honestly, it's really complex stuff, and I recommend looking into regular expression at some point, but that's not for this video right now. And that's everything I'm going to cover in this particular video. So that's everything for this one. We will pick it up again in the next one with more useful commands. So see you over there.